Hi students, today we are going to see the class 10 chapter 1 relation and function, right? In our early classes we have studied about the set, right? Set means a set is a collection of well defined object. The extension of the set is the relation and function. In this chapter we are going to study about the what is the relation and what is the function. Before we see the introductions, what is the ordered pair? First one is the ordered pair. In our day-to-day life, without knowingly or known, we have used the pairs, right? For example, I give the example for this. For ordered pair, what is the 1 liter of milk is 40 rupees, right? And then 1 kg of tomato is 10 rupees, right? So 5 liters is equal to 200 rupees. So 10 kg tomato is 100 rupees. And then when we are going to buy one shoe, we say first the color of the shoe is black color. And then what we have say, or otherwise the shopkeeper what will ask you, what is the size of the shoe, right? So in our day-to-day life, we are using the pair, right? This is in the one form of ordered pair. We say it is a one form of ordered pair. The ordered pair is always mentioned inside the product bracket, right? So these all are called the ordered pair. We have a lot of examples like this. Black shoe and then size. When you go to the tailor shop, or you are going to buy one shirt, right? Shirt, then what will be they ask? What is the size of the shirt, right? Size. These are the ordered pair. Now one of the students is saying, my class teacher asked me to sit in the last bench. Almost that is the last bench. Middle or whatever may be the third seat, the last bench in a third seat. I request my teacher, I can't be able to see the board clearly, and after my teacher asked me to sit in the third row, third bench, right? Third bench, first seat. They allotted me a third bench, first seat. So these are the examples of ordered pair. So last bench, third seat, and then third bench, right? Third bench, first seat. First seat. These are the examples for ordered pair. And then in the lower classes we have used the graph, right? X coordinate and Y coordinate within the bracket, right? So this is called the ordered pair. This is the ordered pair, X and Y axis. So now why we are studying about the ordered pair means the ordered pair is the main role of the relation. Whenever we are finding the relation should be right in this format only. So that's why we want to know about the what is ordered pair. Now such numbers are called the ordered pair. So now such a number pair is called a ordered pair of a numbers. Now you can be able to understand what is the ordered pair, right? Now we see the Cartesian product. What is the Cartesian product? First of all, the Cartesian means in a graph, Cartesian is introduced the graph, right? So in a graph we have using X and Y coordinate axis, right? That is called the Cartesian form. Here we are using the Cartesian product. How we are going to product the Cartesian? For example, let me take it at two sets. The set 1 and then set B. Then see how we are going to product. In set A, let me take it as when you are going to the marriages, what is the special things in the marriage? First one is the bride and grooms, and the next one is the food. So when the food items are like, take it as kesari, K, vada, and then pongal, and then dosa, or some other idli or whatever may be rice. Let me take it as first one is a kesari, second one is a vada, third one is pongal, and then idli. Now set B is a first one is father, second one is mother, third one is son, another one it may be a daughter or only one son, whatever may be. So the set A contains the food items, set B contains the family, right? Particularly in a marriage, how they are distribute the foods? First they have arranged the table for the family, and then the servant will serve the foods one by one. So let me take it as the set like this. It is a set A, this is set B. So kesari, vada, pongal and idli, and father, mother, son and daughter, right? When the servant came to serve you the food, means how will they serve? First one the kesari will be taken by the servant and it will be supplied to the father, because they are sit one by one after, right? So first they put the kesari to father, and then they put the kesari for mother, and then to the son, and then last into the daughter, right? So this is the order, right? If one of them, one servant is not given the kesari to the son, means what we will have to do? We have shout, right? So that is the format. Here Cartesian product means when the first one that is taken, means it should be served to all, and then you have to select the next one. So this should be written in the form of Cartesian product. It should be written in the form of ordered pair, right? So kesari served to the father, KF, comma, and then kesari served to the mother, and then kesari served to the son, and then kesari served to the daughter. இதுதான ஃபார்மேட்டு. ஃபஸ்ட்டு கேசரி எடுத்தாங்க அப்படின்னா லைனாக உட்கார வச்சுருக்காங்க. கேசரி எடுத்தாங்கன்னா எல்லாருக்கும் வச்சுட்டு போகணும். அதுக்கப்புறம் வடை எடுத்தாங்கன்னா அதே மாதிரி எல்லாருக்கும் ஒன் பை ஒன்னாக அவங்க சர்வ் பண்ணிட்டு போகணும். அதே மாதிரி தான் சர்வ் பண்ணுவோம். இல்லை சர்வ் பண்ணாமல் நம்மளை விட்டுட்டு அடுத்தவங்களுக்கு போனாங்க நம்ம சும்மா இருப்போமா? இருக்க மாட்டோம் இல்லைங்களா? ஸோ தட் இஸ் த கார்ட்டீசியன் ப்ராடக்ட். இஃப் யூ செலக்ட் ஒன் திங் தட் ஷுட் பி சர்வ் டு ஈச் அண்ட் எவ்ரி ஒன், ரைட்? நெக்ஸ்ட் வடா எடுக்கிறோம். வடா சர்வ் டு த ஃபாதர், ரைட்? வடா டு த மதர், and then vada to the son, vada to the daughter, in this format. And then next pongal to the father, and then pongal to mother, and then pongal to sister, and then pongal to daughter. Last one is idli to father, and then idli to mother, and then idli to son, idli to daughter. This is the Cartesian product. In this order, the Cartesian product is A into B. Either we can call it as A into B or A Cartesian product of B, right? Simply we call it as A into B or A cross B. That is the form we are using here, right? Now A cross B is, now the first one is served to all of them, right? In case now it will be changed. Now the patterns are changed now. Before the marriage, they serve the food to the guest. Now it is a buffet system. Think about the buffet system. In buffet system, the foods are kept one place. Kesari, vada, pongal, idli. The father took one plate, mother took one plate, and son and daughter took one plate. That is the set B and A. It will be interchanged, right? First one is the old marriage, right? Olden days marriage. The guests are sitting, the food will be served. Now it is a modern marriages, right? It is a buffet system. The food will be kept in one place. The father and mother, son, daughter should be take themselves, right? Now B cross A, B into A, or B Cartesian product of A. How we write the sets? The father took the plate and go take the kesari and move to the vada, right? And then take pongal and then idli. So F comma K, right? F comma V, and then F comma P, F comma I. This is the form, right? And then mother took the plate and go to take the food. M comma K, M comma V, and then mother comma Pongal, and then mother comma Idli, right? Last, that is a son. Son, take the plate and go and take the kesari, and then vada, and son took the Pongal also, and then Idli. And then lastly, daughter went to take the kesari, vada, and then Pongal, and then Idli. Sorry, D. Right? So, when we are doing the Cartesian product, compulsory you have to use the set notation. So, the product form are right in the ordered pair. That's why the ordered pair is very, very important in the relation, right? Now this is the Cartesian product. Now check, A is Cartesian to B is equal to B Cartesian of A or not. First we have to check it. See here in the first KF, right? But in a B into A, if there is a F into K, is it equal or not equal? That is K comma F is equal to F comma K. Is it equal? Surely it is not equal, because the first set element is K, here the first set element is F. Here the first set element is F, the second set element is F, second set element is K. Surely it is not equal, so always A into B is not equal to B into A. This is the condition. When it is equal means both A set and B set are equal, then only we can say A into B is equal to B into A. When we say, when the set A and set B both are equal, right, then only we can say it is equal, otherwise it is not equal. And have you noticed one thing? The first set element always in the first place, the second set element always in the second place, that is K, F, right? This is K is first set element, M is the second set element. When we are writing A as the first set, that set's element should be in the first, and then second set B means the second set element should be here. Now in the second term, B cross A. Now it is a first set is B, so B set's element is F and A set element is K. So here when we are saying that first set means whatever may be the first set, either it is a A or either it is a B, always the first set element should be right first, and then second set element should be right second, right? That is the condition for the Cartesian product. Now we go to the definition for the Cartesian product. So the Cartesian product always in the product form, right? The Cartesian product is always in the product form. Let's see the definition. Now how we write this? So that is A cross B is equal to the set of first set element A and then second set element B, right? A set element A we take it as, and then second set is B, such that A belongs to the first set. The element A belongs to a first set, and then element B belongs to a second set. That is the condition for Cartesian product. Now let's see the definition for this. If A and B are two non-empty sets, why we are using the word non-empty means, I tell you how. This is the definition for Cartesian product. If A and B are two non-empty set, that is very, very important. Non-empty set, then the set of all ordered pair A comma B such that A belongs to A and B belongs to B is called the Cartesian product of A and B, and it's denoted by A into B or A Cartesian B, right? Or either we can say the Cartesian product is also a cross product. We can use the word cross product also. Thus A cross B is equal to A comma B, and then A belongs to A and B belongs to B. Now why we are saying it is a non-empty? Suppose one of the set either A or B is empty. The set A contains some elements, that is 1, 2, 3, and then set B contains, that is empty. Suppose in the definition saying non-empty, right? So here one of the set is empty means then A cross B, that is A Cartesian B, is always empty. That is the condition. Either it is A is empty or B is empty, then we multiple A into B. The Cartesian product of A cross B is always empty set. And then when we multiple the two sets, it represents always the two-dimensional object. By using the graph in lower class, we already have studied about this. By plotting the point like this, and we can mark the points, we can get one object. Like that object is always in a two-dimensional object when only two sets are given. Suppose when the three sets are given, what will represent? When the three set, that is A cross B cross C, is given, means it should be always a three-dimensional object. A cross B cross is given means the term is always three-dimensional objects. That is the condition. A cross B represent always the two-dimensional object. We have used already in the graph, right, in lower classes. Now A cross B cross C represent the vertices cube in three-dimensional object. It will be always in a three-dimensional objects. And then finally we are going to see the set of A, that is n of A is equal to, what are the elements? 1, 2. Now here the set A is equal to KVPI we have taken. The number of A is equal to, what is the number? 1, 2, 3, 4, right? And then n of B is equal to, what is n of B is equal to? 1, 2, 3, 4. So totally when we find that is n of A cross B is equal to always 4 into 4 element, that is 16 ordered pair should be in that form. So simply we can easily find out, suppose n of A is equal to 4, n of B is equal to 4, then n of A cross B, that is A into B, is equal to 4 into 4, that is totally 16 element. Let me check, is it possible, sir? See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this is the one of the way the ordered pair countings, right? The ordered pair is always when we multiple these two sets elements, we get the number of ordered pairs. And next we have told that A cross B is not equal to B cross A. We told that A cross B is not equal to B cross A. By the condition A is equal to B means then only we can say it is A cross B is equal to B cross A. But here number of A cross B is equal to number of B cross A. See that A is multiple with B Cartesian, and then B is Cartesian product of A, means then the number of elements, number of ordered pairs is equal. Now we have already found out at B cross A. When we counted this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So the number of ordered pair of, when we are product the Cartesian, the number of ordered pair A cross B is equal to the number of ordered pair B into A, both are equal. That is the condition. Okay, today we have seen about the ordered pair, how it became by in our day-to-day life. Just think about that examples, you can get the ordered pair, right? And then Cartesian product, I already explained how we are going to product the Cartesian form. Next we see the relation on the next video. Thank you, students.